x on the right hand side. So we're looking at these then. The solution in this case is the form here. There's two parts of the problem. There's a YH part of the problem, which is what we did in the previous section. So I'm not going to say much about that. And it's called the complementary function. So we solve that as we did in the previous section. We just get rid of that, put a 0, and solve it as we did before, writing down the associated quadratic, auxiliary quadratic equation, and then finding the roots, case 1, case 2, case 3. So that's the first part of the problem. I generally draw a line across the page there for that section when we solve that. Then we turn our attention to YP, which is the particular integral solution, and it's obtained by trying a trial and error. We just try something. So whatever's on the right hand side, we try generally according to this table here. So here's our right hand side, possible functions, for example. So if the right hand side has this form, then we would try ax plus b, and substitution, and then we would find the constants a and b. If it had all these forms here, then this is generally what we try, and we sub it in, and then we work out the values of a and b. Generally we end up with a couple of simultaneous equations, or simpler, and just solve for a and b. So I'll give you a little example then of this in practice by looking at a very simple example, just to illustrate the things I've mentioned here in general. So here's an example. Take this simple little second order linear differential equation, which is equal to e to the x, the function of x on the right hand side. There's two parts of the problem, so I've drawn a line across the page here and here to get YH. So you drop the function of x and you put a 0 and solve this as we did in the previous section. In this case it was case 1, 2 real roots, and we've got our solution for YH, the associated homogeneous equation. Once we've done that, we turn our attention to the YP part of the problem, and we try a substitution according to the table that we mentioned. So e to the x. So let's just have a quick look at the table then to see what e to the x would be in this case. Remember we had 1 e to the x, and here's our right hand side, 1 e to the x. It has this form, so we would try a e to the 1x, wouldn't we? So that's what we do here, back in the problem then. So let's have a little look at that. So we try a e to the x, then we're going to substitution to determine a. So you get y dashed, y double dash, simple differentiation. Sub them into the original equation above. So if you look back above here, one of these minus 6 of these, because they're all a e to the x's, aren't they? Notice I put pulled the e to the x out because it was going to run all the way through here and here. And then it's easy to divide by e to the x both sides and read off that minus 4a is 1. So a must be minus a quarter then. And then we can finally write the solution, because the final solution, general solution, is y is equal to YH, which is this part here, plus the YP part of the problem, which is here, minus a quarter e to the x. So YH was that, and YP was this thing here. And put them together, that's a general solution. Now there's only one final thing to remark upon, and that is that if this solution that we have got for YP that we try is already in this arrangement here, then it's not going to work. And you just do it and you think, oh, it didn't work. Oh yes, that's right, because this function's already in the YH solution. And in that case, you just jump up generally by a power of x. So you would try y equals a to the x, e to the x. And then try that and work out the value of a in that case and obtain the solution. So that's one little hiccup, but it comes out in practice. It reminds you, oh yes, I didn't check. There could be a little hiccup here, and then you just try that and get around it that way and write the final solution. So as I say, I hope you enjoy this section, guys, get something from it, and here's a little bit of bookwork that you need, and I'll catch you again in the next section. Cheers!